All right, let's talk about the future of manufacturing. And I want you to forget what you think you know. The loud, clanking robot arms and the noisy assembly lines. The real revolution? It's happening silently, inside the factory's new digital brain. Today, we're diving into how neural networks are completely changing the game from the inside out. So, let's start with a really fundamental question. For centuries, this has been the ultimate goal, right? How do you build a perfect product every single time with zero flaws? Well, it turns out the answer isn't about stronger machines or more skilled hands. Nope, it's about teaching a machine to see things that are completely invisible to the human eye. And this is exactly where neural networks come into play. It's the key that's unlocking a whole new level of quality and precision. So here's how we're going to break it down. First, we'll look at how AI sees the unseen. Then, how it optimizes, well, basically everything. We'll touch on its role in designing the future, the super important place for humans in all this, and finally, what it all means for our assembled future. Okay, let's kick things off with the most hands-on application, quality control. This is all about spotting tiny flaws before they can become massive problems. So, the classic way to check for these flaws is something called non-destructive evaluation, or NDE. Think of it like giving a steel beam an X-ray or an ultrasound. The whole point is to find microscopic cracks or weaknesses without actually having to break the component apart. It's absolutely critical, but man, it's also slow, and it takes an incredible amount of human focus to do it right. And this is where things get really cool. You take all the data from those scans and you feed it into a specific kind of AI called a convolutional neural network, or CNN. The best way to think about it is like a superhuman set of eyes. It's been trained on millions of images, so it can scan all of that complex test data in real time and spot a defect so small that a person would almost certainly miss it, especially after hours of staring at a screen. So, how does the AI get so smart so fast? Well, it's got a couple of really clever tricks up its sleeve. First, there's transfer learning. That's kind of like an AI learning to find cracks in a pipe, and then using that knowledge to start looking for flaws in, say, a wind turbine blade, without having to start from scratch. Then you have data augmentation. The AI can take one single image of a defect and create hundreds of slightly different versions of it to train itself. What that really means is you don't need a million real-world examples to get the AI up to speed, which makes it incredibly fast and flexible. And look, this isn't just some theory in a lab. The impact is huge, and it's happening right now. As this quote points out, we're talking about critical industries like nuclear power and railways. Just imagine finding a hairline crack in a train axle before it leads to a derailment. This tech is literally preventing catastrophes, making things safer, and saving companies from unbelievably expensive downtime. Okay, so finding tiny flaws, super important. But that's just the tip of the iceberg. Now we're going to see how that exact same kind of intelligence is being used to optimize pretty much everything in a factory, making the whole operation smarter, faster, and way more sustainable. I mean, just look at the sheer variety here. In the energy industry, AIs are fine-tuning fuel cells to squeeze every last drop of power out of them. In drilling, they're sensing the forces on a drill bit in real time to make the process faster and a whole lot safer. And in renewables, they're helping solar panels track the sun with absolute precision, which boosts their efficiency day in and day out. And it's not just about optimizing what's happening in the here and now. It's also about predicting the future. Neural networks have gotten so good that they can forecast the energy needs for an entire city's worth of electric vehicles, or they can predict a power plant's output. That kind of foresight allows for smarter planning, a more stable power grid, and, at the end of the day, lower emissions. So we've gone from the physical world of drills and solar panels. Now let's go behind the scenes to the digital backbone of the modern factory, the design process itself. Think about all the work that goes into just designing something. It's tons of tedious manual work. Well, AI is starting to automate all that heavy lifting. It can scan these super complex digital blueprints, engineers call them BIMs, and just pull out all the key information instantly. And here's where it gets kind of wild. Some AIs can now teach themselves how to generate these incredibly complex airflow patterns for simulations, a job that used to take a whole team of specialists. And this digital intelligence doesn't just stop at the factory door. The global supply chain is this massive, tangled web, and it's vulnerable. So now there's specialized AI models that scan everything, digital footprints, online chatter, to sniff out potential threats. And get this, they're doing it with 91% accuracy. That is incredible. It's like having a digital bloodhound protecting every single shipment. Okay, so with all this talk of automation and intelligent machines, there's always the big question, right? Where do we, the humans, fit into all this? This part is so important because it shows that this tech is really about augmenting our abilities, not just replacing us. And check this out. These are two fantastic examples of how AI is making the factory a more human-friendly place. On one hand, you've got gesture recognition. It lets workers, including folks with disabilities, communicate with machines just using natural hand movements, no complex controls. On the other hand, you've got wearable AI that can actually read text or identify objects for workers who are visually impaired. That's a huge step forward for safety and for independence. And it even goes as far as changing the way a factory sounds. Instead of an operator having to stare at screens and dials all day long, deep learning is creating these incredibly realistic voice assistants. They can give verbal updates and alerts, which really cuts down on mental strain and fatigue. It sounds like a small thing, but it has a massive impact on focus and safety. So we've seen AI as an inspector, an optimizer, a designer, and even a coworker. Let's pull all these threads together now and ask, what does this quiet revolution really mean for the future of how we make things? Here's the key thing to take away from all this. The smart factory revolution isn't an army of loud, clunky robots. It's an invisible layer of intelligence that's woven into every single step of the process. It's the neural network making sure a part is perfect, a process uses less energy, a design is better, and a worker is safer. It's making everything more precise, more efficient, and more secure than we ever thought possible. And that really brings us to our final thought. The smart factory isn't some sci-fi dream anymore. It's here. It's being built as we speak. So the question is no longer how we build things, but with this incredible new level of intelligence at our fingertips, what are we going to build next?